Welcome, class. We are in quantum numbers. Let's go. Under quantum numbers, there are four numbers you should note on. The four quantum numbers, we have the N, we have the L, we have the ML, we have the MX. Remember, on the channel, we don't like wasting time. Now, you have to know what the N is. The N is the principal quantum number. The N is the principal quantum number. The L is the azimuthal quantum number. And not only that, you can call it the angular momentum. And then you call it the azimuthal or the angular momentum quantum number. The ML is called the magnetic quantum number, while the MS is called the magnetic spin. Now, this as a principal quantum number describes the energy of the shell. The L, which is the azimuthal quantum number, describes the shape of the orbital. Now, the ML and the MX. The ML specify the orbital within the subshell. Like I said, it specifies the orbital within the subshell. I'm taking my time to do this because, believe me, there's a lot of calculations here. And then the MX is the magnetic spin. And under magnetic spin is either plus or minus 1/2. You will see it in a minute. You will see it in a minute. Now, let's continue. If there is, let me say, a hydrogen under my video on electronic configuration, and let me say we have a shells here. Now, under principal quantum number, this is the first shell, which is n is equal to 1. This is the second shell, which is n is equals to 2. And this is the third shell, meaning that n is equals to 3. So if I should draw a diagram like this and ask you how many number of shells inside this diagram, what it means is we have 3 shells. And that means that the number of the principal quantum number there is 1, is 3. We are taking it easy. Believe me, this topic is full of calculation. It's very sweet. The topic is very sweet. But if you do not pay attention, you may get confused along the line. Now, remember I said the azimuthal quantum number tells you about the shape, and there is something you should know. Under electronic configuration, we have what we call the SPDF. This is introduction. If you miss this, you will find it difficult. And so, under SPDF on electronic configuration, like I said L gives off the shape. And so under magnetic quantum number or the quantum numbers, whenever the L value is 0, we're talking about the S subshell. Whenever the L value is 1, we're talking about the P subshell. Whenever the L value is 2, we're talking about the D subshell. Whenever the L value is 3, we're talking about the what? The F subshell. Know it very well, it's very important. Now, under this, remember also, we need to know the shape and some question. Remember that, of course, S is spherical. The shape of S is spherical. And then the P is dumbbell. And D is double dumbbell, while the F is a complicated shape. I'm taking my time to introduce the course proper, because like I said, we have a lot of things to do here. Now, let's go. I want you to note something very important. Boom. Whenever the N is equal to 1, the L value must be 0. Note it very well. And remember, whenever the N also, the shell is 1, the shape, which is 0, means that you are in the what? The shape of the orbital is S, That means it's spherical. And if I say that, we're going to come to that in a minute. Let me take the topic one step at a time. Now, like I said, if n is 1, the number of subshell is 0. And if n is 2, that means the number of subshell we are into or the p subshell. And you should know that we have 2s and what? 2p. Now, if n is equals to 3, the number of subshell should be 3s, 3p, and what? 3d. Now, if n is equals to 4, that means we have 4 subshell, and that means we should have 3s, 3p, 3d, and what am I doing? Sorry, we should have 4s, 4p, 4d, and 4f. Now, I want you to know something. The maximum number of electrons that the s will contain is what? 2. The maximum number of electrons that p will contain is 6. The maximum number of electrons that d will contain is what? Is 10. The maximum number of electrons that f should contain is 14. Now, if you notice something here, you notice that they are increasing by what? A factor of what? 444. Remember, this is introduction. I wouldn't want in a situation when I start dissolving the video, questions will start arising. Now, I want you to know something. We have to know the relationship between L and ML. The relationship between L and ML. Now, note, I already said that when we're talking about L, we're talking about the shape of the orbital, the subshell. Now, if our L is 0 or is 1 or 2 or 3, we already know that we're talking about when L value is 0, we're talking about the s orbital. When the L value is 1, we're talking about the p. When it is 2, we're talking about the d. When it is 3, we're talking about the f orbital. Is it not? Good. Now, what is the relationship between L and ML? Now, the relationship between L and ML is easy. The relationship here is that ML is equals to starts from minus L to plus L. Therefore, what it means is if my L is equals to 1, that means the value of my ML must be automatically from minus L to plus L. So it's going to start from minus 1. So we're going to be counting down, down, down. So minus 1, then 0, then what? 1. That's the value of the ML. And if my L is equal to 3, that means your ML will now start reading from minus 3, comma minus 2, comma minus 1, comma 0, comma 1, comma 2. So the relationship between L and ML starts from what? Minus L to plus L. And I just said at the beginning of the video that no matter what, that N and L can never have the same number. What am I saying? If your N is 3, your L can never be equal to 3. It's not possible. Now, let's continue. And like I said, having introduced the relationship between, I want to talk about the whole quantum numbers. I've talked about N, I've talked about L, I've talked about ML, I want to talk about MX. And like you just know that MX is the magnetic spin. But then there's an interesting thing about this. Remember I said, I told you if, and clean this side of the board. I told you that if we have L to be equals to 3, we now know that our ML will range from minus L to plus L. Now, MS as the magnetic spin, it ranges plus or minus 1/2. Now, for example, right now, let's say we are dealing with under the L we have S, P, D, F, and now you already know that the number of This we have one orbital here. The S contains one orbital. Now we can call it the subshell. How many subshell are in X? Is one subshell. And how many subshell does P contain? We have 3 subshell in P. How many subshell does D contains? We have 5 subshells. 1, 2, 3, 4, 5. And then how many subshell does F contain? 1, 2, 3, 4, 5, 6. We have 7 subshells in F, right? Now, following the principle of Hund's rule, remember electron will go singly first before what? Pairing. So electron will go singly first. They will first enter singly before you now start what? Pairing them. Now, the magnetic spin, all it wants to show us is the arrow either upward or downward. Now, if the arrow is facing upward like this, your magnetic spin is immediately plus 1/2. But if the arrow is facing this way, your magnetic spin, the answer is minus 1/2. Take note of it very well. When we start applying calculations or solving calculations under this, you will understand it perfectly. Now, we are still under introduction. That should be it for this.